Hi everyone, so we are going to be talking about diffusion and osmosis. So for a lot of you, we've already talked about diffusion. So the diffusion part's going to be a recap, and we're going to be talking about osmosis. So let's get started. So the one thing that we need to remember is the parts of the cell. So we talked a lot about the parts of the cell. So we've talked about the mitochondria, which is being highlighted with the pointer right here, which is really important in cellular respiration, how basically the cell burns glucose to produce ATP, which is your cell's form of energy packet. The nucleus, where all of the genetic information of the cell is stored, which we're going to be talking about a lot soon. And then what I'm highlighting right here, which is our cell membrane. And our cell membrane controls what enters and exits the cell, which is actually extremely vital for diffusion and osmosis because the cell membrane controls things that go in the cell and things that go out of the cell. So our cell membrane is controlling the movements of our inputs. So our inputs are things the cell requires. And our outputs. And again, our outputs are things that leave the cell either because it doesn't require it, it's considered a waste product, or it needs to go somewhere else. So when we're talking about the cell membrane, it is vital because it controls what enters and exits. So it's also considered semi-permeable, meaning that it allows only certain things to cross easily. Which is actually going to be extremely important when we're talking about the difference between diffusion and osmosis. But first we have to actually understand why diffusion and osmosis is important, which is because it is trying to reestablish concentration equilibrium. So there's two words we need to define here. Our first is concentration. Our second is equilibrium. So the first word, concentration. So this is a flashback to probably when we talked about mixtures last year, when we're talking about if something is concentrated or not concentration, we're looking at the amount of solute dissolved in our solvent. So when we're talking about things that are concentrated, they're usually homogeneous solutions. Actually, they're usually always homogeneous solutions, and homogeneous solutions, we really cannot tell what's dissolved in it. So it looks like a pure substance. So a classic example of a homogeneous solution would be salt water. Excuse me. So if we look at our image right here, we have a diagram of that. So we can see that we have our solvent, which in biological systems are going to mostly be water. And then we have our solute, which is represented by our little circles right here. Now, when we're talking about our solute, really it can be in any state of matter, so solid, liquid, or gas. But for what we're talking about a lot, if our solute is a gas, it's going to be either oxygen or carbon dioxide. And if our solute is a solid, it's basically going to be a salt. So salt being our key example. So when we're talking about concentration, it's how much solute we have dissolved in our solvent. Now, the second word we have to define is equilibrium. So equilibrium is when two sides of a barrier are balanced. So our barrier that we're talking about right here is going to be our, you guessed it, the cell membrane. So basically we want the inside of the cell and the outside of the cell to be balanced. So when we're talking about diffusion, it's our solute that moves across the cell membrane. And in diffusion, the solute is usually going to be in a gas form. So it's usually going to be oxygen or carbon dioxide. And the reason why it's going to be in a gas form is because gases can go across, so can transfer across the cell membrane extremely easy. So it usually goes by diffusion. So what's happening is moving from an area of high concentration to an area of low concentration across the cell membrane. As a result, because diffusion usually happens with gases, there's no change in cell size because the gas can easily dissolve within our solvent. So we're not going to have our cell changing in size. So we're going to see some images to show this. So if we're looking at this right here, we can see on the outside of the cell, we have a higher concentration of solute than on the inside of the cell. So what's happening is I'm moving from an area of high concentration, so outside the cell, to an area of low concentration, which is inside of the cell, and then I have a balanced concentration. Because my solute is usually a gas, I'm not changing the size of the cell whatsoever. So the cell stays the exact same size. So we see here that we have the high concentration going in, and then we have it balanced. The exact same thing happens if we have the second scenario. And in our second scenario, we have a high concentration on the inside of the cell, a low concentration on the outside of the cell. The solute leaves to balance the low concentration on the outside of the cell, and we get equilibrium. So in diffusion, to recap, and the key thing that we need to say is that our solute moves. The solute moves from an area of high concentration to low concentration, and the size of the cell stays the same. Now, our solute moves because it can move easily. So most often than not, the solute is a gas. In osmosis, the solute is not going to be a gas. It's going to be a solid, and it will not move easily through the cell membrane. So it has to be something else that has to move, which we're going to see right now. So in osmosis, it's the water that moves because the solute can't. Now, our semi-permeable membrane is our cell membrane. And if we're looking at this diagram right here, we can see that we have water and we have salt. And salt is our solute, and it's also a solid. And one thing that you'll need to notice is we need to notice the shape of the salt. It's actually quite big. So because it's quite big, it cannot fit through the small gaps in between the cell membrane. The water can. So what has to happen is the water needs to move, in a sense, to dilute the concentration. So what's happening right here is that our water has to be moving across the cell membrane to dilute the concentration of our solute because the solute cannot move easily. So solute, like salts and minerals, can't easily move across the cell membrane, so the water has to move. So basically what's happening is that the water is moving to dilute the high concentration. So because the water is moving to dilute the high concentration, there is going to be a change in the size of the cell. It's either going to get bigger because water has to enter the cell, or it's going to get smaller because water has to leave the cell. But the key thing is the solute cannot move easily. So because the solute cannot move, the solvent has to move to bring down the concentration. So it goes from a low solute concentration to a high solute concentration. And it does this because it needs to dilute the solute. So you want to think of it as like you made hot chocolate, right? So if we're making hot chocolate, we have our container, we have our chocolate powder, right? And we have our liquid inside of it, right? And if you made hot chocolate and you found that it was too sweet, well, what's the one thing that you do? You probably add more water or you add more milk, right? So if you're adding more milk, what you're doing is you're basically diluting your solute. So you're basically adding more liquid to spread out the concentration, which therefore brings your concentration down. That's what's happening in osmosis. The solute particle can't go through the cell membrane, so something has to go in to bring that concentration down, to spread it out more. And what goes in is the solvent. So the cell either gets smaller, so shrinks, and it gets smaller because the solvent, which is our water, exits, or it swells, so it gets bigger. And it gets bigger because our water enters. So we're going to see an example of this. So if we're looking at our first example right here, we see that we have a high solute concentration outside the cell. Now, because the solute cannot move easily, water has to bring that concentration down. So water has to go there to dilute it. So if water is going to dilute it, it has to leave from an area where it was low to begin with, so inside the cell, and go outside of the cell. So since water is leaving, the size of the cell gets smaller because the water is coming out. As the water is coming out, it's basically diluting the outside, bringing the concentration lower. So in this situation, the cell gets smaller. But the opposite is also true if the situations were reversed. So let's say the high concentration is inside the cell. Now, again, the solute cannot leave easily, so the solvent needs to come in. So that means water from outside needs to enter to dilute the inside. So if it's entering to dilute the inside, the cell is going to get bigger. So our key thing in osmosis, it's the solvent, which moves, and it's the solvent that moves because the solute can't. This causes the cell to change sizes. Hope this helps.